The mesons are a lower energy than the gluons. So the mesons in the SUSY inversion model are part of the atomic process that results in the tunneling and entanglement between the quark and the electron, and that is also observed between the quark and the positron. So when the neutron has two down quarks and one up quark, one of the down quarks is exchangeable. And the down quark is positively charged and the positron is positively charged. So we really have in the neutron, even though the neutron's negatively one charged, it contains two down quarks and an up quark. And you think, well, a down quark in the SUSY inversion model is +1, so we've got two pluses and a minus. You add them together, you would end up with +1 for the neutron. But if you multiply two pluses and one minus, you get a negative. So it's a little bit strange, but in the SUSY inversion model, you use multiplication, but you can also use addition. So you can see the +2 overall charge of a neutron-positron pair when adding is used, and you get an overall charge of 0 when you multiply the quarks together, where the neutron becomes -1 because you've got two down quarks which are positive and one up quark which is negative. Multiply them together and you get -1, and the positron is +1, so overall it's got a charge of 0, so it's stable. So it is both stable and unstable depending on which way you look at it. And it's really that feature of the proton and electron and neutron and positron that gives the attractive binding force within the nucleus, because the hadron surrounding the hadron in the nucleus, so if it's a neutron, it has a negative quark surrounding the two quarks and the gluons, bound together by the gluon. It's a bit easier if I've got an image in front of me. But so in these numbers here, we're starting with 4e to the -18, which is the size of the positron and the electron based on the diameter. And as you can see, there are relationships between them, the distance being 4e to the -14, that's the Hebig singularity. And we move into the emission of alpha particles and the Planck particle, so dark energy and dark matter. And we've got the opposite trajectories down at the singularity for the dark matter, and the inverse of that is 6.25 e to the 34. And there's that relationship as well between the dark matter and dark energy particles corresponding to the decay process that I want to talk about, that creates the He32 and the H10. So if we use the inverse square law, we end up getting 2e to the -9 and 1.6e to the -35. So those have a relationship together as well of 8e to the -27, which also correlates to 1.25 e to the 26, and that's the number of Planck lengths away from the singularity, which is taking the electron up to the scale of the orbital layers within hydrogen. So that first n = 1 layer at 91.2 nanometers for the Lyman line, corresponding to 5.7 e to the 27. So it's slightly larger than what I've specified. That's around 2 nanometers there. But it's well outside of essentially the atomic event horizon corresponding to the 1/c². and way larger than the singularity down at the Planck scale within the atom nucleus. So the model really gives a way of understanding how the quantum tunneling and entanglement process occurs between the photon, positron, electron pairing in this atomic geometry of a cross, and how inverse square law can be used to understand the singularity state and how that inverts the charge on the positron and the electron to become the different charged quarks. So this is an internal geometric rearrangement that's occurring within the atomic structure of the atom in order to stabilize through a mirrored symmetry of opposites. And it's that central point that really provides a greater understanding of atomic geometry within the nucleus and the processes that are at play in atomic decay of isotopes and the geometry that's required for beta decay to occur. So the model gives a framework based on mirrored symmetries through the center point. And by understanding the original geometry, we can understand the process whereby a positron-electron pair is generated, and we can understand how quantum tunneling and entanglement of two photons is responsible for producing the quark geometries. And the electron in the proton case and the quark geometries of the neutron and the positron. So this mirrored symmetry state that provides a inverted symmetry is very useful.